In this video, we're going to be using structure of equations to determine the number of solutions that that equation has. In order to determine the number of solutions for an equation, it's important to simplify each side of the equation as much as possible. All right, this might require you to combine similar terms on one or both sides, to use the distributive property on one or both sides, or to distribute and then combine similar terms on one or both sides. Now, once each side of the equation has been simplified, look at the structure of the equation to determine the number of solutions. There are three different cases that we're going to be looking at once we've simplified each side of the equation. Case number one, if both sides of the equation have the same variable with the same coefficient, and they also have the same constant, then the equation will have infinite solutions, which means it is called an identity. Okay? If your constant's the same and your variable and coefficient are the same, then there will be an infinite number of solutions. If both sides of the equation have the same variable with the same coefficient, but the constants are different, then the equation will have zero solutions, no solutions, which means it is called an inconsistent equation. An inconsistent equation. And this is because, well, I can write an example. Same variable and coefficient on the same side, but different constants. So something like this, 4x minus 3 equals 4x plus 7. If I subtracted the 4x from each side, then that's going to leave me with negative 3 equal to 7, which is never going to be equal, okay? So if the same variable and same coefficient are on both sides, but different constants are on both sides, then the equation will have zero solutions, which means it's called an inconsistent equation. Now, after you simplify, if both sides of the equation have the same variable but different coefficients, then the equation will have one solution. It doesn't matter if the constants are the same or different. Okay, so if they have the same variable but different coefficients, that's when we're going to have one solution. So what we're going to do in the next part of this video is try to see if we can look at the structure to determine, is there going to be an infinite number of solutions because it's an identity, no solutions because it's an inconsistent equation, or will there be just one solution to the equation? In example number one, we're going to look at an equation and try to figure out what has to go in the blank for the equation to have infinite solutions. And if we recall from back up here in the box, number one, we said that there are infinite solutions if both sides of the equation have the same variable and the same coefficient and the same constant. Looking at this equation, we have 5x plus 14 equals blank x plus 14. Notice that the constants are the same. Okay, so they have the same constant, so for there to be infinite solutions, they have to have the same variable and the same coefficient. Well, the variable is going to be the same. So in order for this to have infinite solutions, we're going to have to make the blank be a 5. All right, 5x plus 14 equals 5x plus 14. The blank should be 5 because equations with infinite solutions have the same coefficient and the same constants. All right. Equations with infinite solutions have the same coefficient and the same constant. So that blank had to be a 5 to match the 5x on the left-hand side. In our next example, we're going to figure out what number needs to go in the blank here so that the equation will have no solutions. And reviewing our information in the box above, we said that an equation will have zero solutions if the equation on both sides has the same variable and same coefficient, but different constants. Okay, so looking at our equation, all right, we have blank x plus 13 equals negative 4x minus 10. And looking at the constants, on the left we have positive 13, and on the right we have negative 10. So the constants are different, which is what we needed, different constants, but both sides have to have the same variable with the same coefficient. Therefore, looking at this example, since they have to have the same variable and same coefficient, this blank needs to be a negative 4. All right, the blank should be negative 4 because equations with no solutions have the same coefficient and different constants. All right, the same variable and different constants. If we were to add 4x on each side of this equation, that would make the equation say 13 equals negative 10, which is never a true statement. Okay, so as long as both sides have the same coefficient and different constants, that means that your solution or your equation will have no solutions. In our third example, which number should go in the blank so that the equation has infinite solutions? And once again, to have infinite solutions, both sides of the equation need to be exactly the same. So they need to have the same variable and coefficient, and they also have to have the same constant. And looking at this equation, 2x minus 4 equals 2x plus blank, I can see that they have the same variable and coefficient. So now they have to have the same constant for the equation to have infinite solutions. Since the constant on the left is negative 4, then the constant on the right is also going to have to be negative 4. The blank should be negative 4 because equations with infinite solutions have the same coefficient and the same constants. In example 4, we want to know which number needs to go in the blank here so that the equation has no solutions. All right, well, if I look at the left-hand side of this equation, I'm actually going to have to simplify this before I can figure out what needs to go in the blank. So what I'm going to do is use my distributive property here. I'm going to do 3 times negative 1x, which is negative 3x, and I'm going to do 3 times positive 4, which is positive 12, equals blank x minus 9. Now that I've simplified this left-hand side, I can determine what has to go in the blank here for the equation to have no solutions. If we recall from earlier in the lesson, we said that an equation will have no solution if the constants are different, which we have different constants here, positive 12 on the left, negative 9 on the right, but the variable and coefficient are the same on both sides. So since the variables are the same, x and x, the coefficients also need to be the same, which means that this blank needs to be a negative 3. The blank should be negative 3 because equations with no solution have the same coefficient and different constants. Once again, if we were to take this equation to constants, we would add 3x to each side, which would then make the equation say that 12 equals negative 9, which is never true. Therefore, this equation would have no solution. In our next example, we need to determine what number has to go in the blank here so that the equation will have one solution. And if we recall from earlier in the video, we said that for there to be one solution, both sides of the equation need the same variable but different coefficients. Okay, it doesn't matter if the constants are the same or different. What does matter is that the coefficients are different. And so if we look at this example, we have 3x minus 7 equals blank x minus 7. All right, we don't need to even pay attention to the constants, even though they're the same here. But what we do need to have is different coefficients. All right, which means since I have 3x here on the left, I can put any number here in the blank except for the 3. So in this spot, I'm going to say the blank should be any number but 3. because equations with one solution have different coefficients and the same or different constants. Once again, it doesn't matter if the constants are the same or different, but the coefficients have to be different for there to be one solution. So any number except for 3 can go there. So I could put 5 there, for example. 3x minus 7 equals 5x minus 7. That equation would have one solution. In our next example, we have to determine which number needs to go in the blank right here so that the equation will have no solutions. All right, and again, reminding ourselves of what we said earlier, we want no solutions. Okay, well, to have zero solutions, we need to have the same variable and coefficient, but different constants. So let's see if we can figure out what needs to go here. All right, now on the left-hand side, excuse me, on the right-hand side, it says 4x minus 5. Okay, we need to have different constants. All right, and looking here, I have a -5, and over here, I have a +4. So the constants are different. However, we need to have the same variable with the same coefficient. Notice over here, we have an x, which is the same as 1x plus blank x. We have to figure out what's going to have to go in the blank here on the left-hand side so that when I combine this x with 1x, it's going to equal 4x, same variable and same coefficient. Well, 1x plus 3x is going to give me 4x. So now this would say 4x plus 4 equals 4x minus 5. The variables and coefficients are the same, the constants are different, which means this would have no solution. So the blank should be 3 because equations with no solution have the same coefficient and different constants. Looking at example number 7, which number needs to go in the blank so that this equation is going to have infinite solutions? Infinite solutions are going to have the same variable, the same coefficient, and the same constant. All right, and looking at this left-hand side, I have some simplifying that I need to do to determine what this coefficient of x is going to have to be. So what we're going to do, we're going to start off by using the distributive property. 3 is going to multiply -1x, which is -3x, and 3 is going to multiply 4, which is +12, and I'm just going to bring down this 6x. All right, and now I notice here on the left-hand side that I can still combine -3x and 6x. -3x plus 6x is 3x. So the left-hand side is going to simplify to 3x plus 12. And again, on the left-hand side, we need to have the same variable and coefficient and the same constant. Well, this 12 is the same as this 12. The x's are the same, so we just need to make the coefficients the same, which means this blank should be a 3. The blank should be a 3 because equations with infinite solutions have the same coefficient and they have the same constant. Looking at example number 8, which number needs to go in the blank so that the equation will have just one solution? Remember that equations with one solution are going to have different coefficients, and it doesn't matter what the constants are, either the same or different. So let's go ahead and look at the left-hand side first. All right, since my blank is on the right-hand side, I'm going to simplify the left-hand side. I'm going to use my distributive property. -12 multiplies 1x, which is going to be -12x. And -12 multiplies -3, which, or excuse me, 3 rather, which is going to be -36. Equals blank times -2x minus 6. All right, so again, to have one solution, it doesn't matter what the constants are. So I'm not even going to pay any attention to these constants. But what does matter is that these coefficients of x are going to be different. Right now, we're going to have to put something in the blank on the right-hand side so that when it multiplies -2x, it doesn't equal -12x. Well, if we did get -12x on the right-hand side, we would have to multiply by 6 since 6 times negative 2x is going to be negative 12x. All right, but we don't want to have negative 12x on this side, which means that I can put any number in the blank here except for a 6. The blank should be any number but 6, because equations with one solution have different coefficients and the same or different constants. All right, equations with one solution have different coefficients and the same or different constants. If I put a 6 here, 6 times negative 2x is negative 12x, which makes these the same coefficient. So I'm going to put any number except for 6 in the blank here. So maybe I would put maybe negative 2 there. That would make sure that my equation only has one solution.